Okay, good morning to all of you. I welcomes to all in our lecture series on mathematical physics, that is your core paper 5, and we are discussing Legendre differential equation and Legendre polynomials. This is your lecture number 44. In this lecture we are going to discuss about orthogonality property of Legendre's polynomial. The orthogonal property of Legendre's polynomial is given by integration of -1 to +1 pmx into pnx dx equal to 0 for m not equal to n and equal to 2 by 2n plus 1 for m equal to n. So by using Kronecker delta system, that is your delta mn, the orthogonality property of Legendre's polynomial can be represented as -1 to +1 pmx into pnx dx equal to 2 by 2n plus 1 Kronecker delta mn. Actually the Kronecker delta is nothing but 0 when m not equal to n and 1 when m equal to n. So here the same answer we have been written. M not equal to n, it will be 0, m equal to n, it will be 2 by 2n plus 1. So instead of this we can write also using Kronecker delta system in this way. Okay. So these things we have to prove in this video. Let's start. So Legendre differential equation in general Legendre differential equation is in the form of 1 minus x square d square y by dx square minus 2x dy by dx plus n into n plus 1 y equal to 0, or this can be written as in the form of y double dash, and here y is the function of x minus 2x y dash x, this is the function of x, okay, plus n into n plus 1 y is the function of x equal to 0. Let this is your equation number 1. So as p and x and pmx are the solutions of Legendre differential equations, that is your for the differential equation 1, pnx and pmx are the polynomials, or also we can say that pmx and pnx are the solutions of this equation number 1. So hence we can write 1 minus x square pn double dash x, instead of yx we can write pn. So pn double dash x minus 2x pn dash x plus n into n plus 1 pnx equal to 0. Let it is equation number 2. And if we are going to consider pmx, then it can be written as 1 minus x square into pm double dash x minus 2x pm dash x plus m into m plus 1 into pmx equal to 0. Okay, let it is your equation number 3. Now what we have to do, we have to multiply pmx with equation number 2 and pnx with equation number 3. Then what we are going to get, we have to multiply pm with equation number 2, pn, that means pm here it will multiply, pn is going to be multiplied with this equation number 3, pm with 2, pn with 3. What we are going to get, we can get 1 minus x square into pn double dash x into pmx minus 2x pn dash x pmx plus n into n plus 1 pnx into pmx equal to 0. Let it is equation number 4. And whenever we are going to be multiply pnx in your with your equation number 3, then what we are going to get, we can get that 1 minus x square pm double dash x pnx minus pn double dash x pmx, sorry, this is 1 minus x square pm double dash x into pnx minus 2x pm double dash x into pnx plus m into m plus 1 pnx equal to 0. Let it is equation number 5. Now we have to subtract 4 from equation number 5. That means this one is going to be subtracted from this one. So the first term you can see that this first term 1 minus x square 1 minus x square can be taken outside. So here pm double dash x into pnx minus this one pn double dash x into pmx, pm double dash x into pmx. Okay, then minus we have to take common from these two terms. You just watch this one, this minus this one, it will be plus. If I will take minus 2x common, so it will be pm dash x into pnx minus pn dash x into pmx. Okay, then here m into m plus 1 minus n into n plus 1, m into m plus 1 minus n into n plus 1 into pmx into pnx, pmx into pnx. Here pmx, pnx is there, here also pmx and pnx is there. So we can take common as pmx into pnx equal to 0. Let it is your equation number 6. Now we have to consider one derivative, that is your d by dx of 1 minus x square pm dash x pnx minus pmx pn dash x. What will be the value? Let's check. So it will be, see these two terms are the product formula we can first use. So 1 minus x square and this derivative means these two pm dash x pnx both are function of x. Again we have to consider the product formula. So this will be pm double dash x pnx plus pm dash x into pn dash x minus this will be dash pm dash x pn dash x, again it here minus is there, so minus pmx pn double dash x. Okay, plus this much product formula means this, so derivative of this one is completed. Now derivative of this one, so this will be remain same. This is pm dash x pnx, pm dash x into pnx minus pn dash x into pmx into derivative of this one 1 minus x square, that is nothing but minus 2x, minus 2x. So here you can see that your pm dash x pn dash x minus pm dash x pn dash x, both terms is going to be cancelled because this is plus, this is minus. Okay, so we can get this one and this one, this first term and last term. So 1 minus x square pm double dash x pnx minus pn double dash x pmx pn double dash x pmx. So this is minus 2x, so we can write minus 2x pm dash x pnx minus pn dash x pmx equal to 0. Here not equal to 0. So derivative of this one is this one, we found is this one, right? So here we found the derivative, the first derivative of this term, this term we found is this much, right? Now let this is your equation number 7. Use the value from 7 in equation number 6. Now we have to check the equation number 6 and we have to put the value from equation number 7 in 6. Here you can check the 6. 6 is what? 1 minus x square pm double dash x pnx minus pn double dash x pmx minus 2x pm dash x pnx minus pn dash x pmx. This much term is nothing but derivative of this one. See, derivative of this one we found this much, your equation number 7. Okay, derivative of this one is this much, so this much is nothing but this one. Okay, got it? Okay, so now instead of this I can write derivative of this one, differentiation of this one. So using the value of 7 in equation number 6, what we are going to get? So d by dx of, so instead of this I am going to put this one. So d by dx of 1 minus x square, it will be pm dash x pnx minus pmx pn dash x, pm dash x pnx minus pmx pn dash x plus this I just multiplied. This will be m square plus m minus n square minus n, m square plus m minus n square minus n, pm x pn x equal 0, pm x pn x equal 0. Let it is your equation number is 8. Now we have to integrate the equation number 8 with respect to x between the limit minus 1 to plus 1. What we are going to get? So integration of minus 1 to plus 1, the previous page I have been written the equation number 8, the same thing I have been written, nothing else. So integration, that is minus 1 to 1, derivative of 1 minus x square, this bracket term, plus m square plus m minus n square n into integration of minus 1 to plus 1 pmx pnx dx equal to 0. Okay. Now here you can see this is the derivative of this this term, and integration with respect to dx is also there. I forgot to write dx over here, dx. So what will happen? This differentiation will be cancelled. So only this term we have to write with the limit minus 1 to plus 1. See 1 minus x square bracket pm dash x pn x minus pm x pn dash x minus 1 to plus 1. Okay. Then this one will be m square minus n square, m square minus n square, m minus n minus 1 to plus 1 pmx pnx dx will be equal to 0, and this value will be equal to 0 because see whatever may be the value of x, whatever may be the value of here 1 minus x square is there, and this is the function of x, this is the function of x, and this all are the function of x. Okay. So if I am going to put 1, whatever the value I am going to get, minus 1, the opposite value I am going to get. So the limit minus 1 to plus 1, this whole value will be always equal to 0. So here I written 0 whenever I am going to put minus 1 to 1 limit for this one. Okay. You just think that this will be, or in this way you can think, see whatever may be the value inside this curly bracket, leave it. First you put 1 over here. What you are going to get? You are going to get 1 minus 1, 0. Okay. 1 minus 1, 0, minus again minus 1 if you are going to put this one, 1 minus 1, 0. So whenever I will be put 1 for x, this term will be 0, means this whole term will be 0. Minus 1 you have to put instead of x, means this x square will be 1, and 1 minus 1 will be 0, and the whole term will be 0. And this term it can be written as a square minus b square form. This will m minus 1 m plus n plus m minus n. Okay. This m square minus n square can be written as m minus n and m plus n, and this is m minus n. As usual I have been written integration of minus 1 to plus 1 pmx pnx dx equal to 0. And so here pm minus 1 can be taken outside, it will be m plus n plus 1, m plus n plus 1 minus 1 to plus 1 pmx pnx dx will be equal to 0, and this left hand side will be 0. When it will be 0? If m equal to n, right? If m equal to n, then this will be 0, the left hand side will be 0, right? Or we can say minus 1 to plus 1 pmx pnx dx will be equal to 0 for m minus n not equal to 0. Okay, that means see the left hand side will be equal to 0. That means this integral part will be equal to 0 if this part is not going to be 0, right? If this part it will be 0, then integral part not to be 0. Okay, so this part if not equal to 0, this m minus n into m plus n plus 1 is not going to be 0. At that time it will be possible if m minus n not equal to 0 or m not equal to n. So if m not equal to n, this part is not going to be 0. So hence this part, this integral part will be 0. So minus 1 to plus 1 pmx into pnx equal to 0. Let it is equation number 9 for m minus n not equal to 0, or that is m not equal to n. Okay. Now first condition of our generating function we have been found, and second one, that means for m equal to n it will be 2 by 2n plus 1, that we are going to be found out by using generating function of Legendre's polynomial. We know that generating function of Legendre's polynomial is 1 minus 2xz plus z square to the power minus 1 by 2 is equal to 0 to infinity summation over p and x into z to the power n. You just follow the last two videos whenever I discussed about generating function of Legendre polynomial. There we discussed these things in detail. So I also told that you have to remember this generating function, that 1 minus 2xz plus z square to the power minus 1 by 2 summation over n is equal to 0 to infinity p n x z n z to the power n is your generating function of Legendre polynomial. Now squaring both the side, you have to square. Means both the side means the left hand side will be 1 minus 2xz plus z square to the power minus 1 is equal to this much square, right? Now you have to integrate both the side with respect to x, and the limit should have to be minus 1 to plus 1. What we are going to get, see, this is 1 minus 2xz plus z square to the power minus 1. I can write 1 by this much, 1 by 1 minus 2xz plus z square, and we have to integrate minus 1 to plus 1 with respect to x, that is dx by this much. So is equal to right hand side also we can write like this, minus 1 to plus 1 this much dx. Okay, now integrate this. The same thing I have been written here for my easy explanation in this page, that dx by this much summation over 0 to infinity, and here whole square. See, this square means it will be pn square x, and this will be z to the power 2n dx. Same thing I have been written over here. Okay, now integrating this one, it will be 1 by 2z ln 1 minus 2xz plus z square, and limit should have to be minus 1 to plus 1, and here we have to keep this integration as usual, z to the power 2n just I written outside to the integration, and minus 1 to plus 1 pn square x dx. Here put plus 1 instead of x, plus 1, so it will be ln 1 minus 2z plus z square minus 1 minus minus 1 we have to put instead of x. Instead of x here it will be 1 plus 2z plus z square, and right hand side same. Now in case of left hand side you can see implies that 1 by 2z, it can be written as, see, a square minus 2z, this is z only, 2 into z is there, okay, now this is nothing, 2z plus z square, that means 1 minus z square minus this is 1 plus z square formula. Okay, so then 1 plus z square. Okay, and left hand side, right hand side is the same. Then I can write, see, this is minus is there, if I will be multiply this minus inside the bracket, this plus term will become this side, the first. So 1 by 2z ln 1 plus z square, this is came this side, 1 plus z square minus ln 1 minus z square, ln 1 minus z square bracket closed is equal to summation over whatever previous same thing I have been written. So here square is there, so ln to the power ln 1 plus z square can be written as 2 ln 1 plus z minus 2 ln 1 minus z. So 2 can be go outside, so 2 by 2z ln 1 plus z minus ln 1 minus z, right hand side as usual I have been written. So here 2 got cancelled, it is 1 by z ln 1 plus z, the Taylor series of 1 plus z ln is nothing but z minus z square by 2 plus z cube by 3 and so on, minus ln 1 minus z expansion, Taylor's expansion about z equal to 0, minus, this is minus bracket, minus z, this is z, minus z square by 2 minus z cube by 3 minus so on, and right hand side I kept same before and after. Okay, now this is, see here, minus minus will be plus, here minus z square by 2 will be got cancelled, that means even power will be cancelled out. So I can found the, and the odd powers means minus minus, it will be z, here it will be 1z, it will be 2z, this is z cube by 3, here minus minus z cube by 3 plus 2z cube by 3, so odd power only remaining we can found, and other your even power z will be cancelled out. So 1 by z 2z plus 2z cube by 3 plus 2z 5 by 5 plus so on is equal to 0 to infinity z to the power 2n minus 1 to plus 1 pn square dx, pn square x dx, same thing, nothing changed. So here z, whenever I am going to multiply 1 by z multiplied with each term we found, and 2 common, take common outside, so 2 into 1 plus z square, here z divided means it will be 1 plus z square by 3 plus z 4 by 5 plus it and so on, it will be z to the power 2n, okay, z to the power 2n by 2n plus 1. This, see, second term, so nth term if we are going to consider, then it will be z to the power 2n and the denominator will be 2n plus 1. See, it is 4 divided by 5, that means if I am going to consider 4 over here, 2 over here, it will be 4 and it will be 2 into 4 plus 1, like that, and so on, is equal to n is equal to 0 to infinity z to the power n minus 1 to plus 1 pn square x dx. Okay, now come to the next page. Comparing the coefficient of z to the power 2n on both the side, what we are going to find? See, on the right hand side we have z to the power 2n, left hand side also we have z to the power 2n. The coefficient of z to the power 2n on the left hand side it will be 2 by 2n plus 1, right hand side it is minus 1 to plus 1 pn square x dx. Now we are going to be correlate or compare, then I can found minus in 1 to plus 1 pn square x dx equal to 2 by 2n plus 1, or this pn square can be written as pnx into pnx dx by equal to 2 by 2n plus 1, let it is equal your equation number 10. So by comparing equation number 9 and 10, 9 what we found? Equation number 9 we found minus 1 to plus 1 pmx pnx dx equal to 0, and here we found minus 1 to plus 1 pnx same nn dx equal to 2 by 2n plus 1. So by comparing 9 and 10 we can write minus 1 to plus 1 pnx into pnx dx equal to 0 if m not equal to n, equal to 2 by 2n plus 1 when m equal to n. Here m equal to n means n, or this can be written with the help of Kronecker delta. So pmx into pnx dx minus 1 to plus 1 2 by 2n plus 1 Kronecker delta mn. Here the Kronecker delta is 0 if m not equal to n, 1 when m equal to n. So hence proved. This is your all about orthogonality property of Legendre polynomial. Oftenly it is asked in your exam up to 6 mark. So you write down it perfectly in your note, practices it and prepare for your exam. If you have some problem for understanding in this video, you can contact, we are going to be discuss. So thank you so much for watching this video. Thank you.